So here's what you have to do to tell if this is a linear function or not. What you're going to do is you look at the x values in the table, and you're going to check what they're changing by every time. In other words, you can see here from this number to this number, did it increase or decrease? And you can see here that it did increase, and it went up by 2, right? -4 plus 2 is -2. And now I check for the next pair. So from here to here, how much did it change by? I can see, again, it increased by 2 because -2 plus 2 is 0. And then the last one, 0 plus 2 gives me 2. So I can see, again, we have a constant rate of change for the x values. It's a constant rate of change because every time it's increasing by 2. Now we're going to repeat the same thing for the y values. What is it changing by? And you'll notice that in this example, from here to here, there was no change. So we can say that it increased by 0, no change. And then that repeats, right? Every single time, it doesn't change at all. From here, 2 plus 0 is 2. 2 plus 0 is 2. 2 plus 0 is 2. So the change was nothing. It changed by 0 every time. And even though it didn't change, it's still a constant rate of change because the change was by 0. So since we have a constant rate of change for the y values and a constant rate of change for the x values, meaning it increased by 2 every time, and here it increased by 0 every time, then I know for a fact this is a linear function. And I'm going to show you what they mean by linear function. If you look at the word linear, you'll see the word line in there. So what this is saying is that if you were to plot these points, the relationship is a line. So the relation will be a line. So let's just plot the points so you can get an idea. So I'm going to set this up. So -4, 2, we have to plot -2, 2, 0, 2, and 2, 2. So this should be enough to graph it out. So -4, 2 would be left 4 up 2. -2, 2 would be left 2 up 2. Then I have 0, 2. So 0, 2. And then the last one, 2, 2. So right 2 up 2. And you can see here, look, if I were to draw a line through this, a straight line will pass through every single point. And this is why it's called a linear function, because you're able to draw a line through all the points. In other words, these points form a line. We call this collinear, but that's what they're looking for. If it's a linear function, you want a straight line. If it was not a linear function, you would have something like this, right? It would be like a parabola, a U shape. It could be like a zigzag, something like that. So again, linear function wants to see, is it straight? And you can tell if it's straight or not without graphing it by just looking at the change in the x values and the change in the y values. And once you see that these are all the same and these are all the same, you know 100% that that's a linear function.